In this video, we learn about the chain rule for differentiation. Now, the chain rule for differentiation is a method for differentiating composite functions. So for instance, by the end of this video, we'll know how to differentiate f of x equals to sine of 3x squared minus 1, or y equals to the square root of cosine of x. The chain rule itself can be summarized by two formulae, each of which are completely equivalent. The first of which is the following. If a function f of x can be written g of h of x, in other words, if we're dealing with a composite function, then its derivative f dash of x is given by the following formula. F dash of x equals to h dash of x times g dash of h of x. Make a note of that. Another way of writing this is the following way, which we're calling formula 2 here. And it states that if a function y can be written as y equals to f some function of u, then the derivative dy dx will equal to dy du times du dx. Now both of these formula are referring to the same thing. They are both the chain rule. The first formula tends to be for those who are more comfortable memorizing a formula. The second formula really highlights the fact that we are making a change of variable, and we'll be learning about changes of variables at a later stage. Now let's get our hands dirty and work through a few examples of the chain rule. Okay, now as a first example, we're going to differentiate the function f of x equals to sine of 3x squared plus 1. We're going to do this twice though, and each time we're going to use one of the two formula that we've learned for the chain rule. And the reason for that is we're going to highlight in each case how to use it, of course, but also we'll highlight the fact that no matter which one you choose, you'll get the same result. So, looking at f of x equals to sine of 3x squared plus 1, we can see that this is a composite function. Indeed, we can see that if we call 3x squared plus 1 h of x, and if we call sine the outer function g, then this is g of h of x. In other words, it's a composite function. And so one of the formula, or one of the ways of writing the chain rule, is if f of x is equal to g of h of x, then its derivative, f dash of x, will equal to h dash of x times g dash of h of x. Now that's one of the two formula we saw for the chain rule, so I'll just box that now. There we go. Done. Now, going back to our function, we can see, of course, that if h of x equals to 3x squared plus 1, then its derivative h dash of x will equal to 6x. Also, if g, the outer function, or g of x, equals to sine of x, then its derivative will be g dash of x equals to cosine of x. And now, using the chain rule, we can state that f dash of x, the derivative, equals to h dash of x times g dash of h of x. And replacing each of these functions, h dash, g dash, and h, by their respective expressions, leads us to 6x times cosine of 3x squared plus 1. And there we have it. We've just differentiated this function using the chain rule. Now, the second way we saw to write the chain rule was as follows. If y is equal to some function of u, so I'll just write f of u of x, then the derivative dy dx equals to dy du times du dx. And in fact, that's probably the most popular way of writing the chain rule. So knowing it really is quite important. So, going back to our function, we have y is equal to sine of 3x squared plus 1. So here's the idea. If we let u of x equals to 3x squared plus 1, in other words, we've just defined a new variable called u, then of course du dx equals to 6x. And we can rewrite our function y as y is equal to sine of u. And so the idea now is to treat u as a variable, just in the same way as we would when we have sine of x, and write dy du equals to cosine of u. And so now, bringing this all together using this formula for the chain rule, we have dy dx equals to dy du times du dx, which is cosine of u times 6x. Replacing u by its expression, 3x squared plus 1, that's equal to cosine of 3x squared plus 1 times 6x, which we can write as dy dx equals to 6x times cosine of 3x squared plus 1. And so there we have it. We can see that we actually get exactly the same result here and here, regardless of which of the two formula we use. So that's our first example. Let's look at another. Now, as a second example, we're going to differentiate f of x equals to x squared plus 1 over x, all of which is raised to the power of 6. Now again, we're going to do this with the 2 formula. So to begin with, we can think of this as g of h of x. In other words, it's a composite function. And indeed, if we call x squared plus 1 over x h of x, and the outer function, which is the power of 6, or x to the power of 6, that's g of h of x. Now, remember, the formula is, if f of x equals to g of h of x, then the derivative, f dash of x, will equal to h dash of x times g dash of h of x. So, let's just box that result again, really quickly. Now, comparing this to our function here, since h of x equals to x squared plus 1 over x, h dash of x equals to 2x minus 1 over x squared. Now, I'll quickly point out, if you don't know the derivative of 1 over x off by heart, I strongly suggest you learn it. It comes up all the time. So the derivative of 1 over x is negative 1 over x squared. There we go. Now, the outer function here, remember, is g of x equals to x to the power of 6. So the derivative would be g dash of x, which equals to 6x to the power of 5. Now, using this formula for the chain rule, we can state that f dash of x, the derivative, equals to h dash of x times g dash of h of x. And now replacing each of those, h dash, g dash, and h, leads us to the following. H dash was 2x minus 1 over x squared times g dash of h of x. Well, g dash was 6x to the power of 5, so g dash of h of x will be 6h of x to the power of 5. And since h of x was x squared plus 1 over x, that's 6 times x squared plus 1 over x to the power of 5. Rearranging this a little, we have 6 times 2x minus 1 over x squared times x squared plus 1 over x to the power of 5. And there we have it. We've just differentiated this using the chain rule. Now, we could go a little further and simplify, of course, but that's not the purpose of this video. Okay, now let's differentiate this again using the second formula we saw for the chain rule, which was if y equals to some function of u of x, then dy dx will equal to dy du times du dx. And let's just box that result. There we go. Now, let's rewrite our function as follows. Y is equal to x squared plus 1 over x raised to the power of 6. To differentiate this using the chain rule, the first thing we're going to do here is define a new variable. And we're going to call that variable u. And u is equal to x squared plus 1 over x. Now that we've done that, we can see that we can rewrite our function y solely in terms of u, so that y is equal to u to the power of 6. Okay, now we're going to look at the derivatives. We know that du dx, the derivative of u, would be 2x minus 1 over x squared. And y, now that it's a function of u, we can figure out its derivative with respect to u. That is, dy du equals to 6u to the power of 5. And now we've done all the groundwork necessary to use this formula for the chain rule. Indeed, we can go ahead and write dy dx equals to dy du times du dx. And dy du was 6u to the power of 5. We had just found that there. And du dx we had found above. That's 2x minus 1 over x squared. So that's 2x minus 1 over x squared. And now replacing u by its expression, remember that was x squared plus 1 over x, we find 6 times x squared plus 1 over x raised to the power of 5 times 2x minus 1 over x squared. And that's the expression for dy dx. And now we see that this is exactly the same result as what we had obtained previously. These two expressions are the same. So once more, this highlights the fact that both formula lead to the same result. They are the same thing, but they simply look a little different. Now let's look at one last example. Well, let's differentiate with respect to x. F of x equals to the square root of 3 cosine of x. Now once more, we'll do this using the two formula, or the two ways of writing the chain rule that we saw. So, the first way, if we let this inner function, 3 cosine of x, if we let that be h of x, then the outer function, square root, would be g of x. So that's g of x equals to square root of x, and h of x is 3 cosine of x. Now one final time, let's remind ourselves that if f of x equals to g of h of x, then the derivative f dash of x equals to h dash of x times g dash of h of x. And again, we box this result very quickly here. There we go. Now, since h of x equals to 3 cosine of x, the derivative of this would be h dash of x, which equals to negative 3 sine of x. Also, we have g of x, which is the outer function. G of x is the square root of x. And the derivative of this, g dash of x, is equal to 1 over 2 root x. Now, if you don't know the derivative of square root of x off by heart, I strongly advise you to learn it off by heart. It comes up very frequently, so remember, if we have square root of x, its derivative would be 1 over 2 root x. Now, back to this function. Using the chain rule formula, we can go ahead and write f dash of x equals to h dash of x times g dash of h of x. And so we can say that since h dash is negative 3 sine of x, g dash is 1 over 2 root x. So g dash of h of x would be 1 over 2 square root of h of x, which was 3 cosine of x. That leads us to f dash of x equals to negative 3 sine of x over 2 square root of 3 cosine of x. And there we have it. We've just differentiated this using the chain rule. Now, let's differentiate this using the second way of writing the chain rule. So to begin with, let's write y equals to the square root of 3 cosine of x. There we go. Now quickly, we'll remind ourselves that if y is some function of u, so some function of u of x, then dy dx equals to dy du times du dx. And that's just another way of writing this first formula. So, quickly boxing that, there we go. Now we're going to let u, or u of x, equal to 3 cosine of x, so that its derivative, du dx, equals to negative 3 sine of x. We can also see that since u of x equals to 3 cosine of x, y can be written as y equals to the square root of u. And now we can differentiate y with respect to u. In other words, as though x wasn't there. The only variable there is u. And so we need the derivative of the square root of u, and that would be dy du is equal to 1 over 2 root u. And we're done. All we need to do now is use this formula inside the chain rule. And so we can write dy dx equals to dy du times du dx. And we saw that dy du was 1 over 2 times the square root of u times du dx, which was negative 3 sine of x. This leads us to negative 3 sine of x over 2 times the square root of u, and u was 3 cosine of x. And there we have it. We see that we get the same result with this second formula. And so that's how we use the chain rule. I hope that helps.